Hello, good evening, everyone, and a very warm welcome to each one of you to IGBC Green Building 101, a special session brought to you by Discover Arc in collaboration with IGBC and Kapurthala Hoshiarpur Subcenter of Indian Institute of Architects. Discover Arc is a dynamic platform dedicated to promoting architectural awareness, education, and innovation among students. Through curated competitions, expert led sessions, and collaborative initiatives, Discover Arc empowers young minds to explore design thinking, sustainable practices, and the future of built environment. So it is an absolute honor to welcome our speaker, architect Jit Kumar Gupta, a pioneer in urban planning and sustainable architecture. He has served as Chief Town Planner of Sharda Prime City Limited, advisor to Punjab Urban Development Authority, and Director at College of Architecture, IET Bada. With vast experience in eco-urbanism, he continues to guide and inspire architectural community nationwide. So without a further ado, let's welcome architect Jit Kumar Gupta to take us through the IGBC Green Building 101.
Good evening, Tanya. I
Good
think
evening, sir.
it's a both honor and pleasure to be speaking on this occasion on the green building itself. So we'll be detailing about what the buildings are, what the role and relevance of buildings, and how the building can be made more sustainable. So I hope, I'll be able to communicate with you the intent and contents of the building, and also the approach you can use for making buildings sustainable. Most of the things you must have read it. It may be a repetition, but despite a repetition, I think they are important and relevant for all of us to understand. My PPT is visible. Tanya?
Yes, sir. Yes, sir. PPT
Is
is
it visible?
visible. Yes, sir.
Now you can see it full?
Yes, sir.
Okay. Thank you. So I think first we have to understand what buildings are, because we are all connected with the buildings, and we take buildings are just made of brick and mortar. No, buildings are, living entities, because buildings have been an integral part of the human history. And the day we came on this planet Earth, we started making buildings. And we'll find, that building will stay on till the humanity is there. The moment we as a human being all leave this planet Earth, there will be no building. So therefore, entire growth and development of humanity is depicted by the buildings itself. So building is a man-made environment. There exists two environment. One made by nature, that's a natural environment. Other by human, that's man-made environment. And there's always a conflict and contradiction between natural environment and man-made environment. A green building tries to basically minimize the conflict and those contradictions which exist within these green buildings. So therefore, I think this is what has to be understood, that buildings are relevant, building were relevant, and building shall continue to be relevant, because all human activities are performed within the four walls of building. And if you analyze and dissect your life, 80% of human life is spent within four walls of buildings. You are born in a hospital, you are educated in a school, you go and work in an office, you live in a home, you work, or you go for entertainment in any shopping mall. All these are building itself. So you are spending 80% of your life in the buildings. So therefore, buildings are relevant, and building carry a message for you that they have to be good and sportive of the human living. So if the building have positivity, buildings have negativity. For the reason buildings are the largest consumer of energy, resources, waste, and generator of waste. And they are the prime reason of global warming, environment, and ecology. So therefore, I think once you know the buildings have positivity and they have negativity, I think that's where we have all to see that buildings are made rational, they are planned and designed in such a manner, they not only help humanity, but they also preserve the nature and biodiversity. So buildings have their own connotation, and the studies have already made, a green school make building learning much easier and much meaningful. A green house makes people happy, healthy, and more productive. A green hospital care patient very quickly, and green shopping mall increases sale. And in fact, please understand, sustainable buildings create a win-win situation for a owner, occupant, and the user. And the context of the building you can see is human being, because human beings require everything for their education, healthcare, their study, their stay and work, etc. So as the human numbers are increasing, the demand for building is also growing. And with rapid urbanization, you will find more and more people are opting for cities, and they are migrating to cities where new kind of buildings are there. So therefore, the context of building is going to be relevant, and there are, people, the more and more buildings will be constructed, and you will see the building typology will go on changing. But please understand, buildings are never finite. Nobody can say this is the final building. Buildings are always evolving, devolving, and this is all depends upon, your material, your technology, etc. So therefore, in India, when we are, having largest population, we are growing very fast. The population itself, we are getting urbanized. You are finding building construction is getting, faster and faster. And it is said only 60% of the buildings have been constructed. 40% are more to be constructed by the year 2050, by 2050. And this is what you have the, numbers before you, because they say we are going to be 160 million, 1.6 billion by the year 2050, and 50% people will be living in urban India. They are only estimates, but India, we have already 1.41 billion 2020-30, and we are growing at the rate of 20 million every year. 2 crore people are being added annually in the Indian population. So therefore, we are likely to reach these figures much quicker. But these are all having implications. There will be new cities. There will be existing cities will be expanding. So therefore, you'll find, buildings will be required. But I think once we are talking about building, we have to look for what is the role and relevance of building. And buildings have, I said, building have positivity and negativity. They have implication, and this slide will tell you how the buildings are impacting our resources, our environment, and how these buildings are need to be taken care of more rationally and realistic by the architects and the engineer. If you look at this, the water which is drawn, 1/6 of the water goes in making a building. Similarly, 1/4 of the wood harvested. 1/3 of the total raw material which is extracted on the earth is making in building. So energy, carbon emission, municipal waste, and ozone depletion, chlorofluorocarbon. And you finding 30% of the people who are queuing up in the cities are suffering from sick building syndrome. So therefore, I think buildings have, you can see the building have role and relevance in water, energy, material, waste, carbon, and also, making people happy and healthy. So therefore, I think it's important to understand that buildings have to be looked more attentively, more rationally, so that you do a good job, because the role and responsibility of architects remain very critical. Because if you design a bad building, I think the buildings is going to do great injustice, not to humanity, but also to the environment. Just look at the gentleman, he's Vitruvius, the father of architecture. And he was the first person, he was chief engineer in Roman, and he was the first person to lay down 3 principles for any building. And he said a building must comply with 3 things. Number 1, building must be useful. Number 2, building must be safe to live in, and thirdly, you're durable. And thirdly, the building must be beautiful. So, utilitas, vanistas, They were the three principle which was enunciated by, you know, the, the father of the architecture. But it was, I found out it is not only these three, that's beauty, utility, and safety, because building involve cost, quality, and time. You are spending money. And in addition, to realize that buildings are not only these six factors, buildings are also consuming resources. Buildings are also impacting biodiversity and environment. So therefore, I think these nine parameters, that is cost, quality, and time, and then utility, and beauty and durability, plus conservation of resources, biodiversity, and environment. Plus, building have the local and the global context. You don't think whatever you do, if you do a wrong building in India, it will impact the environment globally. Or if you do a good job, then it is going to positively impact. So the buildings are not only having the local context, it is going to have the global context. If you dissect the building, a building has 7 layers, before the entire life cycle of the building. First, you start look at the site, then you get into the design, you construct it. Once the building is constructed, you occupy it, you start operating, and during operation, you maintain it and renovate it. And after the building outlived the life, or you want a new building to come in, you deconstruct the building and then doing this. And all these 7 layers basically involve what all the time, it's involved it's consumption of energy, water, material, and natural resources. And what in the process it does? It generate waste, it pollute air, water, and indoor air, It create heat island, and it leads to flooding and noise. And in the impact of cumulative effect of all these factors is harm to human health, there is environmental degradation, and there is a loss of resources. So therefore, I think the building, you can see the positivity and the negativity of building, and it has been categorically said the buildings have to be looked very carefully, because buildings are known to generate carbon dioxide to the extent of 10 gigatons. 35% of the global carbon dioxide emission you can attribute to the buildings, Water, I said, energy, I said, waste, I said, and in India, the the studies have been made by McKinsey Global Institute. They said India needs 700 to 900 million square meter of built up space annually. So we know, the building have impact on the human health. They are impacting environment, ecology, resources itself. So therefore, if we have to remain sustainable, I think building needs to be looked critically, differently, distinctly, and we need to appreciate the role, relevance of the building, that they need to be planned, designed differently. And I think as professional, you all know, there are options available with us to make building more realistic, building sporting of the environment, and least consumer of energy and resources. But option could be, you can do what? You approach, you look building holistically as one unit. So you have integrated approach to planning and designing of the building. Secondly, you have to look for the design your building with respect response to climate where the building is being there. Option will be work with nature, because nature provide all kind of solution and all kind of resources, and the nature resources provided by nature, they're all renewable and they are never exhausting. And then you have to look for material which, if you look at the material which are green, I think you do a good job. Similarly, you use technology which is sustainable and resource sufficient, you will be able to achieve your destination of sustainable building. Then this, we talk about the new buildings, but if you also retrofit the existing building, then I think we will do a great job of making building more sustainable. So therefore, in order to achieve the kind of things that building consume less resources, water, energy, generate less waste, and provide best of the indoor air quality, we have to look building differently and distinctly. We have to plan building in a different fashion, and the new typology of building which is coming is green, and sustainable building. That's what, we are looking at. Then this is what the 17 sustainable goals you have been looking at and you are familiar with. What we are concerned with goal 11. Goal 11 says, in order to make this world more sustainable, we have to make our cities and human settlement. They have to be made inclusive, safe, resilient, and sustainable. And this can happen only. There are two things, cities are consuming 70% of energy and 70% of resources. And this we have to minimize. And there are two areas which are consuming major resources and generating waste. Number one is the building, and the second, where you are traveling. So if you make your building sustainable, least consumer of energy and resources, and if you can minimize the travel, and you can shift people traveling from, the traveling from fuel-driven, fossil fuel-driven to electrical or other sustainable this goods fuels, you will do a great job. So after we have done our job and we look at, that if the green buildings are option, let's understand what are the green buildings. So when you look at the green buildings, please understand there are 5 elements which constitute a green building. So wherever a sustainable building and green building issue will come, these 5 principles will form the underlying, foundation for designing this concept. So a green building is number one, which uses less water. Number two, optimizes energy efficiency. Third, conserve natural resources. Fourth, generate less waste and provide healthier space for occupants as compared to conventional buildings. So please understand, there is nothing more and nothing is less. These are the 5 principle you will keep in mind. So that means you will design a building which will be consumer of least amount of water and energy, then conserve natural resources, generate less waste, and provide best of the indoor air quality. So a green building, when you look at these, when you design these building on the 5 principles, you will be able to reduce energy consumption up to 50%, water 40%, carbon emission 1/3, and solid waste reduction 70%. And the benefits of this green building, when you look at the green building, because buildings are going to be there for 60 or 70 years, there are two, you will have to understand that building, every day when the building puts into operation, it costs money. The day you start constructing the building, even I said those 7 layers, you are going through this, they are involving energy, water resources, etc. So if you want this building to be cost effective, if you want the, operation cost of water, energy, those bills should be reduced. You should have minimum maintenance costs. Then, you go for a green building. In addition to reducing your cost of operation, green buildings are known to add value because you will fetch more rental because this building is, having minimum operation cost. Then you are attracting all foreign national, all companies, multinational companies which are coming in India. They are first finding, whether the building is a green building because they know, there is a lot of money involved in paying the electricity bill and water bill. And in addition, it, increases the asset value. In addition to, those tangible benefits, the intangible benefits is because you are reducing impact on environment, because you are using less resources, you are depending more on the natural and renewable sources. So therefore, you are not destroying flora and fauna, etc. So you are minimizing impact of environment. And then, if you are giving a very healthy environment for people to live in, so that they will not fall sick, they will not be absent, So what they will do, they will be more productive, they will be more happy and healthy. And studies have already done, that people living in, had these sustainable building have higher cognitive score more than 102, and sleep more than 40 minutes. They are 8% more productive than other, and they contribute to the prosperity and the profits of the building where they're about. So I said building have implication in terms of reducing energy consumption, water consumption, and carbon emission. And if you design 1 million square feet of green building, you are reducing carbon footprint by 8,000 to 12,000 ton every year. Your electricity load will go down to 3 megawatt, and similarly, your solid waste will be reduced by 70%. So you are reducing water, you are reducing everything, and what in cricket, what they say, a run saved is run scored. So if you are spending less, that means you don't need, if you are consuming less energy, that means the new plants will not be required to be electricity, those, thermal plants or other energy will not be required to be there. So if you are reducing your water requirement by 40%, that means your water resource will last much longer. So if you are having less waste, there will be less number of lorries which will be required to transport that kind of things. So therefore, in fact, this green buildings will help you by not only helping the environment, society, but also creates a win-win situation for you by generating wealth itself. But when let's look at the cost of the building. But whenever you do a project, always do two kind of solution. That is, when you are looking at, when you are designing a building, there is one initial cost, there is one life cycle cost. Life cycle cost means the duration which the building is planned, designed, constructed, and that's 7 layers. Like we have the life cycle, we are born, then we are children, and then we become adult, we become elder. After we finish, then we leave this planet Earth. So that is our life cycle through these 4 stages we go. Similarly, building has those 7 stages. So building is going to stay here. Maybe, there are buildings, you already know buildings are 1,000 year, 2,000 year, but normally if you take the life of building of around 70 to 80, so you will have to, number one, work. What is the initial cost? That is the short-term cost. And what is the total operation cost? Because buildings are like machines, they are consuming energy, they are consuming resources, they are generating waste, etc. So you will, and this is costing money. So therefore, I think you will do a study in terms of, the initial cost and the life cycle cost. So initial cost may be higher by 3 or 4%, but you will look at the life cycle cost in case you want the building to be sustainable. And please understand, only 10% cost is the cost of construction of building, whereas 90% is the cost of operation and maintenance. So if we are looking at only an initial cost, you are ignoring the operating and maintenance cost. So therefore, both the cost will have to be done, but more emphasis will have to be, how the building behaves, etc. And this is the study which has been made. First building, green building, which was constructed in India, was the CII Godrej building. This is a footprint of 20,000 square feet. It was constructed in 2003. And it was costing 18% more that the normal one, because at that time nobody knew, that what is the green building. All material was being imported over the from outside, and it was Mr. Grover who designed this building. This building was the first building, platinum rated building, to be constructed outside India, outside America, I would say, because this was a lead rated building. So therefore, over a period of time, this has been studies been done. Then IGBC green building cost, which was constructed in 2004, had 15% cost. And the last building, Switzerland One Earth, which was done in 2010, it had a, footprints of 800,000 square feet. It was again rated platinum, the highest rating in the IGBC. And it costed only 2%. And the 2% cost was recovered in 2 years, and then building went on saving the cost. So you can see that if somebody question you, the building, green buildings are very costly. No, please understand, these are the study which has been made, and this is cost is decreasing. Decreasing in the sense because people are knowing, what green building is. So therefore, those elements are embedded during this planning and designing of the building, so building cost less. This was the first building which was talking about. This IGBC headquarters in Hyderabad, which costed 18% more. And this is the, Switzerland, One Earth, which is called constructed in 2010, even, only 7 years after the first building was constructed. And this costed only 2% more, and this is the one finest building. And that's what, you will see over a period of time, the cost of the green building will be as good as the normal building, like you had, earlier when you were having those black and white pictures, and the colored films were colored photographs were very, very expensive. But over technology, with the technology, colored photographs are now much cheaper as compared to the black and white. So therefore, ultimately, maybe green building may be costing less than the initial, than the normal building itself. Now question comes, after we have gone through the definition, after we have gone through the context of the building and the need for a green building, we will see, how the building can be designed as a green building. So these are all which you are be studying, you have already studied. That means now, first thing you are going to do is what? You are adopting an integrated approach to the building. That means buildings looked holistically as a human, body, and where every point is taken care of. Then, number two, building will have to be designed based on climate. And when you look at the climate, you look at the climate in three contexts. What is the regional climate? That's a macro climate, mesoclimate, climate at the city. And thirdly, you look at the site. What is the site climate? Because the regional climate is a broad issue, local climate is more specific, but site climate is with which you will be concerned. Then you will look at the orientation, you will look at how the movement of the sun, you will also map the wind direction, and then you will plan the building, because when you are looking at the site, there are a good site, good direction, there are bad direction, because north, south, east, and west have their own implication. Therefore, you will have to do what, because you have to define your requirement into two paths, the spaces which are used for human living, spaces which are not used for human living. So all good orientation can be used for spaces for human living, and all those where the human intervention is minimum, they can go to the, poor kind of those orientation. So then building envelope is the one which gives you the all personality, which tells you what is the height, what is the, openings, etc. Because you have to make sure the natural light and ventilation is assured. And therefore you have to see, what is the opening, with direction which they are, where you are used to protect it from the sun, etc. That will be, designing envelope. Then material. What material going to be used? Please understand, material will remain very relevant and important, And material in a green building, if you want to be reduce the energy level of the building, so therefore you are, number one, you are using material locally. They will be used in the natural form. They will be having their own less weight, so that the load of the building is reduced. Then they should require minimum of maintenance and upkeep, and they should have a longer life. You should not have material which will get, damaged in after use within shorter period, and then you go on replacing. No, material which are local material, nature is good, best architecture, they have provided those kind of material which you can access locally. Of course, you can improve it, and that's what, material context is. Then what technology you adopt for construction of building, it has to be cost effective, material efficient, time efficient, speedier construction, and of course it should generate minimum waste. And last, but the most important is, what is indoor air quality? That means you have to create optimum living condition for resident. One thing you should always understand, we are all looking at building, from outside. Please look from building inside, because you're all spending 80% of your life within four wall of building. If the interior air is polluted, surely you are not going to be happy and healthy. You are going to face a lot of problems, and that is what is leading to sick building syndrome. So indoor air quality remains very, very critical. So this is what, the integrated approach. When you are looking at this, you are looking at the site, you are looking at the, energy, water, material, technology, etc. So that climate also, they are all being looked at collectively, and then they are all important for reaching a conclusion that building is a sustainable building. Second method, what will remain with you is that when you are talking of a green building, don't think, green building means you are painting building with the green color. No, green means nature. So all this universe is made of Panchbhuta. We are all made of Panchbhuta, and we will make use of this Panchbhuta as in the green building itself. So green building will take care of Prithvi, Agni, Jal, Vayu, and Akash. And the context is Prithvi remains your site and site planning. Jal remains your water conservation. Agni is your energy efficiency. Vayu is your indoor air quality. And Akash is daylight, night sky, and pollution. If we use these nature in as an integral part of your planning and designing of building, you may not have the best solution, but you can never ever be wrong. So therefore, please understand these are the 5 elements which how best you can make use of that let's do it. So first thing we come to the site. I think majority of cases where we fault, that we don't look at the design. Whenever a design solution is going given, we are immediately looking at the requirement. We are thinking of a shape, and that I will have a circle, I will have a hexagonal, I will have a pentagon, I will have intersecting squares, etc. We are premeditating a design. But please understand, if you do your analysis of the site, which is very important, you look at the site, and site, you will find the solution are coming from the site gives a message. So you have to understand site, where the site is located, where is north, south, east, west, which is the wind direction, what is the soil bearing capacity if you're constructing a very, tall, multi-story building, you have to have a soil which have the bearing capacity. Then you have to see the topography. Is it level or it's undulating? Because the message of the building will be there. You will not level this, your this site itself. You will retain the site itself and respect the site and see what best you can do. Then what are the trees and what is the natural feature which are existing, and don't try to destroy that kind of then hydrology and precipitation. If there's too much rain or too much this snowfall, you will have nothing to do but to slant. You have the slanting roof, etc. So you have to make sure those rain and snow is taken care of. Then infrastructure remains very, very important, because where infrastructure is located, suppose your water supply and sewerage, municipal water supply and sewerage right in front of your house, you cannot afford to take your kitchen and your bath, everything backside. In that case, what you are going to do, you will have all those the services first taken back and then bringing it out. So you will have to, rationalize how dovetail with the location of building. Then surrounding land uses and building. So what are the, the typology of building which are there? Neither you are going to be too low if they are tall building, because then you will not have a alert ventilation. If you have too tall a building or massive building and the other building is short, you are overshadowing and you are stopping this. So therefore, I think you have to look at the general consensus of what the topography of the site is. And of course, when you are designing, you will look at the site, where are the good views and which are the bad views. If there are hills, there are water, there are water bodies, I think those views are very important, relevant. They can be made use of. And if there are slums, industry, they need to be avoided. So therefore, I think that the site study and site selection, that itself is a study, is a topic, which needs 1 or 2 hours just to explain it and their role and context. After the site is in, and sometimes, site is given, you can't do anything. But I think site planning, Site planning remains important. In fact, what we do, first we design the building and then try to set it within the site itself. No, please understand, your building design should be a response to your site, number one, and the site planning should be done right in the beginning. So you should decide, you are going to have one building, or you will have get two buildings or three buildings, depending upon your requirement and depending upon the nature of your project, so that, and where you are going to place the building. So that will also have to be decided right in the beginning, where the entry is, what is the hard surface, where you are going to do the landscaping, which is the public space, and where the building footprints are going to be there. So this all have to be done as a planning of the site, So please, site planning remains very, very important. Like you are selecting a site, you are studying a site, and the site, when you study the site, you will find, if you analyze site very critically and objectively, number one, you will know, what is the typology building which is going to come in, and then you will see where but the buildings are going to be put in. So I said the principle could be designing with nature, that neighborhood. You have to understand the physical character. You have to evaluate the slope. If the site is undulating, if the site is contoured, you will do what, you will go along the contour. You will not go across the contour. And if you have to go to the across the contour, you will do what, where minimum cutting and filling will be there. So please, second, you will be keeping in view that what generally we do, whatever site is given to us, we try to cover everything. Whatever zoning is given, we start from outside. No, please do one thing. You minimize the fingerprints of the building. You leave more open spaces, because it has meaning. It makes building more sustainable. So therefore, you can raise the height of the building, but reduce the footprint of building on the site itself. Then you have to, respect the site. You don't have to level the site. You don't have to, cut the trees, etc. So minimum damage to the site will be there. And then you are designing with nature and local culture. And if there are bigger, institution, then your role will be what? You don't promote, all this mechanical vehicles. So you will want to let people come and they should park their vehicles, and then, they walk around, this pedestrianization. So your option for planning shall be, you preserve the best things, you conserve, which is trying, which is need to be conserved. And the derelict area, if you are doing in a site, there is already an area which is built up, So you don't start digging the new area. You will start making use of the area which is already built in, so that you cause minimum damage to the other site itself. So therefore, this is what trying to tell you, that try to go along contours where you have to do it. Please make sure you have minimum cutting and filling. And this is what I was saying, when why you reduce the carbon footprint, the footprints of the building, because if there is nothing which is constructed, the rainwater, whatever water falls, 50% will go inside, earth, that is infiltrated. Or 40% will be evaporation, and there will be only 10% runoff. So you will find very little water which will be drained off. So as the construction will go on increasing, you'll find the infiltration goes on reducing, evaporation of water goes on minimizing, but what is increasing, runoff is increasing. So if you are increasing, by your construction, you are covering more than 75% of the building, that is the surface which we generally make it impervious, the ground recharging will reduce from 50% to 15%. That means you will lose 35% of water which will go to inside you, and which was evaporating from 40 to 30, That means 10% you will again lose there. And what are you gaining, That is runoff From 10% will go 55%. Why the cities are getting flooded? You have seen like city like Chennai, like city like Hyderabad, they are getting flooded for the simple reason, that every inch of land in the city we're trying to metal it. And when you are metaling it, the water runs off 3.5 times more than when it falls on a green space. So therefore, the message remains, please have minimum footprints of the building, and then after you have done this, the site and the site planning, now go for the climate and see, all the building will have to be designed in response to climate. So unfortunately, the worst impact of the globalization is, they have destroyed localization. Now you can find the buildings in Shimla, they are same as building in, desert of Rajasthan or in the this coastal area. So please understand that each zone, climatic zone, has its own implication. So the India is divided into 5 zones. Number one, hot and dry. That's Rajasthan and Gujarat. Then warm and humid. That's all coastal area along Bay of Bengal and your Arabian Sea and Indian Sea. Then there is a then there is a climate. Where there is neither too hot no cold. That's a temperate. And then there is cold climate that is you have Himachal Pradesh, you have Uttarakhand, you have Jammu and Kashmir, and you have North Indian states, So, and then you have a composite climate where the climate goes on changing, because climate is always, please understand the difference between climate and a weather. You are designing for climate, not for a weather, because weather changes every minute, every day. And climate is determined on 2 major issues. Number one is the humidity, and number two is the temperature, and they observe it for 30 years, So if the one pattern exists for 6 months in a year, then that is, where the temperature remains very high, then it's hot and dry. It's when it's, a lot of humidity is there, then hot, dry, that warm and humid will be there. So when they are not, there is nothing like, in Punjab, in Haryana, in Delhi, etc., where every 2 months the weather change. You have a, mild heat, you have extreme heat. You have a mild cold, you have extreme cold. Then you have, rainy water coming in. And those are, season. And that's what, but you have to, those are the climate, and this is a composite climate. And that remains a difficult area for this, So therefore, all building will have to be different and distinct. The principle will remain for designing the same, energy, water, resources, etc. So, but these zones have their own implication in terms of light, heat, ventilation, and thermal comfort. So they will be requiring different kind of treatment. So when you are trying to, when the temperature is very high in a zone, so our first job will be, what principle will be, you will reduce heat gain in the building, How you can reduce heat gain, heat is basically gained by what, It's your building envelope. That is your roof and, wall, this outer walls, and their opening itself. So if you are to minimize, if you are designing in a hot area, you have to decrease exposed area. That means you have to take care about orientation. North is one where there is no sun itself. So north will remain the preferred, Then there's thermal resistance, So building will have to be insulated. Then building must have its own capacity. That means building should be not able to transfer the heat inside. That's a massive structure itself. Then heat exchange rate, that air exchange rate have to be minimized. That means you will have to have smaller windows, etc. Then buffer spaces, though the sun doesn't hit directly, on your living area. So rear locks, lobby, etc. are there. Then you are increasing shading, either you are using projections, you are using louvers, but you can use also the trees, landscape, and etc. to, shade the hot area. Then you have to make sure that sun does not get absorbed, So your white, you will have a light color outside so that sun can be reflected. And then wherever the openings are, they are protected, and the glass you put in, that must be have lower solar heat gain coefficient so that, you have minimum intake. And then if the heat is gained, then you make sure the heat is lost immediately. So courtyard was one, cavity walls are other, in case of the cold areas, I'm not going into others because you can think about that, they are similar. But in case of cold areas, there we were, reducing heat gain. Now here we are doing it, reducing heat loss, So therefore you have to capture sun. So in hill areas, please never ever place your building on the northern slope. If you are building your own, because northern side never ever have a sun. So therefore, you have to see that the buildings are only put in south or east or west, so that you can access. So you have exposed area, you can capture sun. Number one, you have to have the building thermal resistance so that heat inside is large capacity you have to build in, and then you have to have colors. The color has to be dark color so that you capture whatever sun is there and you trap the heat. So look at the Shimla, this is all southern slope. This is all designing an hill area. You have opening on southern slope. You have even the solar panel on the southern slope. You have a trombe wall as an option. This wall is what, it's on the southern side, on the wall, you will have a glass. You trap a heat. When the sun hits it, the inner air trapped inside becomes hot and become light. You have an entry, one porous entry below and one exit above. So the pressure difference is already there. It's built in, and the light air moves up, and so you can cool it. So trombe wall is one. This is a solarium which when used there. So number one is this is what when you are dealing with climate. So when you look in the orientation, you can see how the sun moves summer. That is, the sun moves around north, that it rises in the northeast and sets in the northwest, So it goes around 240 and 250 degree in a day, Whereas in the case of winter, it is, the sun moves around south. It rises in the southeast and runs in southwest, So it's only goes for 130 to 40 degree. So sun duration remains less in winter and more in summer, You can see, in the northern side, there is never ever have a sun. So you want a uniform light, you don't want any heat, go for north side. In east and west, the sun is always lower, because sun is rising and sun is setting. Sun is sun is vertical at the south. So the maximum heat is generated on the southern side for the reason the distance between sun and the earth is minimum. It's a perpendicular, and this is a vertical sun. So during the summer, you can cut off the sun by a horizontal projection. In the winter, sun remains lower. The south side, you will have the sun coming in the southern window. So therefore, southeast remains one of the best option in our this. So ultimately, orientation remains very, very important, and you have to see where how you are placing the building, how you are designing the building, how you are putting the opening itself. In our case, and we're in the hot area, its building shall be longer side shall be facing north and south. And shorter will be east and west. And if you ever have an opportunity to visit Chandigarh, in the capital complex, there is a tower of shadow, which tells you how the sun is to be managed. And this is all this, climate can be studied only by one building. This one done by Corbusier in order to make sure to make understand, that how the building, when what, there are 8 directions, north, south, east, west, and northeast, southeast, northwest, and southwest, So they are the 8 direction in which the building can be placed, and they tell you if your building is facing where north side, you don't have to put anything because there is never ever a sun. So east and west, you will need a lower, and in case of southern side, you will have projection, So I said you can do by designing. So they're a good side. I said southeast is good, but west is the worst one. West, why west is worst one? Because the earth also goes on, gaining heat by the sun. So in the evening, the sun, energy will remain same. Why in the morning you said? Because the earth is cool And at 2 o'clock, the Earth has the lowest temperature, and then it's slightly going in this east morning. You don't find very much heat because the Earth is cool. But in the west, when Earth sun sets in, so it is the Earth is also emitting heat, and the sun is also emitting. So west remains west remains the worst one. So you can have your best living conditions south and southeast, and you can have your in the house your living room, your bedroom, your kitchen can be there. But in the case of western side, you can have your parking, you can have those, storage, etc. that you can do. Air movement remains very, very important. You have to see, how the air is there. And if there are multiple buildings, please make sure that the smallest building is placed where in front of the air, so that all those tile building will have all other building will have the accessibility. If you have tall building right in front and then there are, smaller building at the back, you will ever lose the benefit of building. So instead of, having 90-degree angle, if you do 30 or 45-degree, you will have more advantage. If there are number of blocks, don't put in straight line. They have to be staggered to make use of this. This is how, if you are having tilted lower, you would like the air need to go at the body level, and they should not go on the roof itself. So therefore, lower direction of lower, the canopies, and your inlet and outlet, they remain very, very critical. So this is how you will do the cross ventilation. This is how you will avoid if you are, to take advantage of the air. Energy remains very, very important. Let me tell you, energy will remain relevant because we are all consumer of energy, and all human growth and development is linked to energy. So therefore, we will be using energy more and more. But when we're talking of building, number one is that we have to reduce the energy consumption. Number two, we have to shift from black energy to green energy. That's what the context will remain. So we will be having energy efficient building. We will have zero energy building. We will have energy positive building. That doesn't mean building will not consume energy. Building will go on consuming energy. But you have to make sure whatever equipment will see to it, how you can minimize. So when you look at the building, the building consume energy in three parts. One is embodied energy. Embodied energy means energy which goes into making a building, because you are all using material, you are all using equipment, you are bringing things from outside. This is all you are making, they are consuming energy. Then during maintenance upkeep, you have to, do a lot of changes, and that also involved. And then, of course, your heating, ventilation, air conditioning, they always consume energy. So these are the three areas by this. So therefore, you can see 16% energy is the an initial embodied energy, 10% is the recurring energy, but 74% is the operating energy. So in addition to initial embodied energy, you have to make sure that the operation energy remains very, very less. So this embodied energy, that means you will use material which are local in the natural form, and those material which have lesser energy in their production. That is what you have to see while selecting, in order to make sure. And if you procure material in the close vicinity rather than from a distance, where the transport will also involve, so that will lead to increasing the bonded energy. So secondly, what we are trying to do is that number one, you are looking at the way you are designing, and I said the sun remains the best source of light and heating, etc. You are going to make use of this by designing. So therefore, your orientation will come, etc. You'll use the material like you are using a brick, but please don't plaster the brick. The moment you are plastering the brick, that means what? You will have to paint this. And every 3 years, the paint will go away. So therefore, you find, if the material are used in the natural form, if they're local material, you will find things will be much better in them. And then building has the capacity to, generate its own resources. That's what we see this. So how you can use, minimize the energy? That means you will design the building which are response to climate. That is your passive architecture design will come into being. You will have efficient building envelope. You will optimizing the use of daylight itself. And then you will orient the building in such a manner that you have best orientation in the best of the places. So that means you will have minimum use of mechanical heating and cooling. Second is whatever equipment you use, for lighting, fans, air conditioning, laptop, etc. Please make sure that they are all starred so that they consume lesser energy. And of course, then building is generating your own energy, like you have now the photovoltaic cell, you can have wind turbine, etc. And we have not explored the geothermal energy, which remains very, very important and which is available right below you. So let technology work out on this, and we'll be doing more justice to this. So that is one part. And just look at the building, this north light. You don't see any artificial light in there. You can even harvest the, sunlight for lighting the basement, where there is a problem. So you have pipes going there, and you have one top glass till the sun is there. They will reflect the pipe, this light inside, and these are the actual picture of a place of the basement where there is no artificial light is there. And if you want to, reduce the consumption of electricity, you have to make sure the building does not gain heat. So you can have you can have white roof itself. There's one concept so that the heat comes from the roof, and it comes from the walls, etc. So you can have a white roof there, so the heat gets reflected. You can have a green roof, so that minimum absorption of heat takes place. You can have green walls, they are the option. So that when you embed in that, that means there is less soaking of this heat, and you will have, when there is less soaking of heat, that means you require lesser energy. Then we look at the water. Water remains very, very important. And let me also tell you very clearly, number one, the water in India has only 4% water. India has 17.7% of population, and we have 550 million animals, the largest animal. So we require water, but water is only 4% with us. And the two part of the water is frozen in Himalayas, and there we can't access it. So therefore, water has to be, valued, and water needs to be looked into. In this case, also, I would like to add another one point. Please don't treat land as a commodity, because India has only 2.4% of land, and there are 17.7% of a population. So India is the most land-stressed country in the world. We don't have land itself. Land is needed. All development, all your building, all your school, education, all your transportation, this will happen on the land itself. How you can do the land, and other thing is that you have to feed people, and the all food has to come from the land. So therefore, what is it? 2.4% of land, and 17.7% of population, how this equation is going? Yeah, do you have any kind of mathematics? 2.4 is equal to 17.7? Only option available to is how we can use the land. You can use the land 24 by 7 by 365, You can do a same land 2 times, 3 times, like your college is there. If there are 100 people staying in the morning, if the same are in the evening classes, there are double, this infrastructure will be used double time. So therefore, what I'm trying to suggest to you is, please value land. Don't think land is a commodity to be traded. Land is a gift of nature. This need to be preserved, conserved, and the minimum consumption for building and other purpose you have to ensure. So in case of water, it is a refusal. You know it. You will not, where you don't need water, you will not use the water. Then you will reduce water because all those equipment which is required, that you minimize the water, and the water will have to be used multiple times, recycle, reuse, and then recharge. The rainwater harvesting could be there. So these are the option available. If you go to Singapore, they will serve you new water. You will find in Singapore, you get a new water. What is new water? That is the sewerage water which is treated, and then bottled and made available. People are drinking because there's an island, they don't have water. They were importing water from Malaysia. So what they are now, but the technology is so good. Their systems are so perfect. The water which are, this is a WC water, black water, which is there. And you find, there are where whatever water is supplied to you, only 20% water is used. And 20% water is used for your drinking, for your cooking, etc. What rest 80% water is just thrown out. And the water thrown out are two kinds, black water and the gray water. Black water is one which comes from WC, whereas the gray water is one, which is comes out your bath as a bathing, etc., and the kitchen, etc. Those don't have impurities much. They can be used for flushing, etc. So therefore, this is what is very important. Wherever the waters are, you can put aerators on that. You mix the air. So rainwater harvesting remains one of the best option, and then you will have, this you have waterless urine, and we are looking at, waterless WCs. And these all facets, they are all aerators. And then please understand, landscaping remains the major consumer of water, and the grass is one which consume maximum water. So whenever you are doing a landscaping, don't import anything from outside. Your local trees are the best trees because they can survive in your climate and they will require less water, etc. So that is where you have to look at. And there is a phytoremediation, another method. You don't need WC, you have plants, and you put this WC water there. All this sludge is digested and you get fresh water. You don't have to have a septic tank, a STP put in. So by phytoremediation, you can, treat even the black water as water. So what option is then optimization of water demand, use of water efficient system, and then of course recycling and removal. Look at this architecture, this building you must have seen. This is the assembly building of this. And what Corbusier did it, because money was less. So this building was a huge building. This 300 square the feet square, which is planned. So what they did, considering this, they had just two ponds created. So all the rainwater which coming, they were getting collected in these ponds. So number one, this, in micro changes the climate, microclimate, this it reduces the harshness, and so of course the buildings are reflected through this. So the Corbusier did, they made rainwater harvesting as integral part of the design. This is a high court, which has been followed in the same principle. So when look at this plants, you will have a native plant, you will have draft resistant plant, and you will have plant which are adaptive. And then you are basically using in these big green building, there are those aerators which reduce water from 45 liters to the 30 liters. Then WCs, 6 and 3 liters. Then you have, these recycling done in the major areas, and metering is also done. So please understand, water is a elixir of life. So therefore, we need to work, and we also should see that the urban water which we generate, if we can use it for agriculture, because agriculture use 70% of the fresh water from the earth itself. And we have, those products are vegetable. They are produced in such, and the variety such they consume minimum water. We are basically consuming double the water what Chinese are doing for the same amount of vegetation which is being there, and same kind of wheat or rice which is being produced. So these are the ways, how you can minimize, So building material remains very, very important. I said building material, what you should do, if you are, first thing is, don't go for new material. Please understand that if you are looking at the cities, now construction and demolition waste constitute 40% of the total municipal waste. And this is waste which is never degraded. This remains as set, Earlier we were doing what, we are using the low-lying area and we are reclaiming that. Now what is done, that construction and demolition waste is being collected, and now this is being recycled, and they can be used for, making new material. So retrofitting must be taught to you. You please, if you are given a building, that which building is to be, redone. So first, don't demolish the building. Look at the health of the building and see if you can retain the building, because destroying a building is the biggest crime. So number one, if you think you have to destroy a building, you please take out the best material which is available, and just you can use it. So you can, number one, you can use retrofitting as this. Then you can use the salvage material which is inside of it. Then you have, green labeled material which are basically remains very, very, good for human health. And then you are using material which are made from waste, industrial waste or agriculture waste, and you can use material which can be made, which grow very quickly and very fast itself. So this, this is what, this is your, this is fly ash bricks, which is made from the thermal plants ash, which is generated. And, this is one which does not require any firing, etc. So this is very environment friendly. It has less embodied energy, less, it has good, very good for thermal. There is no question of fluorescence, and there is no fire because it's already burnt. Then aerated cement concrete is another material which is very lightweight, which is very good. And it is very good in terms of insulation, in terms of its character, in terms of acoustic, in terms of, this is able to withstand the pressure of the earthquake because it's very lightweight itself. UPVC window, the advantage. They are expensive, of course, but they make the building insulate, etc. The bamboo is the, this is bamboo is the this steel of 21st century. Those, so there now people are using, this research is going on how you can use this bamboo instead of this steel itself. Bamboo has adequate strength, compressive as well as tensile. It is earthquake resistant, it is lightweight, it is cost effective, it is durable, it is fast growing, it is simple in designing. How it can replace your wood, and it can suck your carbon dioxide, etc. And of course, you can do a lot of manipulation with this and improves indoor air quality. Technology remains very, very important. Of course, technology we are not concerned, but technology is one which is very, very important for the building sustainable. And because these technologies are changing very fast, there are two main technology. One is on-site construction, other is the off-site construction. So buildings are being manufactured, The off-site construction has, a distinct advantage in reducing the cost, in making building cost effective, material efficiency. And you find, the building which will take 1 year to do it, it can be done in 1 month, because majority of products are being manufactured in the industry, and they are transported, and you only need foundation and walls few with this. So this is very important in terms of safety, time, and there is no wastage. You don't have to have people and bring material every day because they are not required. You don't need to water even. So this was the first building, Crystal Palace, which was done on this prefabrication itself. India has now a system. They brought in 6 technology, which they are green. They are no lighthouse projects, where these are the houses which will be constructed, and they were done within 1 year, and they are the best technology which are there. Indoor air quality remains very important. I said outside because indoor air quality sometimes 70 times more pollutant. You are spending 84% of the time. And why this is done, because there are what kind of compound you are using in cell. Then for your this all this painting, everything, your furniture and your carpets, they all basically have some kind of chemical because they are chemical based things, and all those chemicals are dissolving, and then we are inhaling this. So you find majority asthmatic, majority of problem are basically out from the indoor air quality. And if there is a moisture inside, you will find moisture has become a very good breeding grounds for the bacteria, and they go on mixing in there, and we go in inhaling and become sick itself. So indoor air quality is one of the most essential part of the building itself. So when you are designing building, please make sure, that indoor air quality remains very important. Otherwise, it will lead to your tiredness, concentration, and because illness. And carbon, the carbon concentration should not exceed 1,000 ppm. So the problem remains poor ventilation, ceiling of the building. If somebody is smoking, and you are using material inside which is toxic, and then lighting is not there, you are having furniture, you are having carpets, which are never cleaned, so therefore there's a noise, and then you damage vegetation, etc. So therefore, I think they have to be looked into, both outside and inside. So you have to bring fresh air, you have to bring natural light, you have to acoustically seal the building. You have to make sure indoor climate remains comfortable, temperature doesn't rise, and building material which is there, that is sustainable. You even, you can use these plants, erica plant, snake plant, and money plant. They are, if you keep inside, they all suck carbon dioxide and leave oxygen. So they improve the quality of air. People say that multi-story building remains more inefficient. This is a building which is 71 story. This is zero energy building. What the architect have done, this is a divided building into three parts. Within two, and there are cavity, you can see on the right side. And he put in turbine there. So when the air was striking, those turbine was moving. So this building generate 24 by 7 by 365, these electricity. And also then photovoltaic cell and other things they have there. And this building remains zero energy building. So these are the, total things which we have said, that this is how the buildings are planned, designed. And when you say the buildings are green, the building, naturally everybody say my green building is a green building. So naturally you were, as you in a class, somebody says I have got everybody's brilliant, but who is first, who is second, who is in first class, who is in second class, you always rate it. And the rating is done on the major marks, So there are 7 parameters on which the building is rated. That is sustainable architecture and design, site selection and planning, water conservation, energy conservation, building material and resources, indoor air quality, and innovation. Those are the 5 which were related. And their marks, the maximum marks are for the energy, water, material, etc. And based on that, whatever there are 52 criteria on basically on which the building is, evaluated. And based on the mark score, you are given, either you are rated. If you are less than 50, you are not given this rating. And then you are given silver, you are rated, then silver, gold, and platinum remains the highest. So let me conclude. I'm sorry I've taken much of the time, but we have already, what I'm trying to communicate with you is buildings are very, very important. And as professional, we will always be involved in doing buildings. So we have to be very careful. We should not consider building as a made of brick and mortar. No, buildings are living entities. They are basically impacting human living. They are impacting the, this climate and ecology itself. So therefore, if this world is to be sustainable, if the human being have to be more healthy and healthy, I think we have no other option but to design for sustainable building. So I think this is what I'm trying to communicate with you. Please look building more differently and distinctly. Make building green, using the Panch Bhuta as way of life, as integral part of your academic and professional learning. And I'm sure, we can all do. And this is all what we expected from you, and all, we hope, So therefore, let me conclude, a green building make you happy and healthy. It provides highest quality of indoor environment. It provides safety and security, optimizes resources, reduces waste, minimize carbon footprints, make building operations simple, technology-driven, cost-effective, and energy efficient, and makes, green building makes business sense and creates a win-win situation for owner, tenant, occupant, community, place, and environment. And that's what, I hope You have the role and relevance, and you will do this great job. I'll stop it here, and if you have any query, let me know about that. I hope you understand what the context is, and this is what I have to communicate with you. Thank you. Thank you for your time and patience. But I hope I have been able to share with you the role and relevance of this. Thank you. Any question? If
Just
you
one, sir.
if you
We
wish, we will, I will share this PPT with you.
definitely.
Yes, please.
So we have some questions from the audience. First off is that they want to know about the challenges that we might face while implementing green building practices in India.
Challenges will always be there because once I said there are principles. Number one is you may not have the building, site of your choice. You will have a challenges in this site. So therefore, I think that is where your ingenuity is there. But there's no problem about that. You can design building when you are designing with nature, you are designing, you understand the climate. You understand the orientation, you understand the site. There will never ever be problem. Only question is you must know the principle, you must know the practices, you must know the ground reality, and you should be very well aware of this, that how you can optimize your design to create the best of the building. And that's what is required out of you. Next, please. Uh, uh, am I answering this or no?
Yes, sir. So next
Because,
up,
yes, please.
we have is, can you name some passive techniques that are underrated, like that we can, use
Passive,
more?
passive rater means you're like, you want, I show you the picture of that factory. This was north light. So you don't need a heat, you need a light, uniform light are coming. So you have to orient your building in the north. Have you ever been to Chandigarh College of Architecture? I wish you could see the Chandigarh Architecture College, which done by Kabuzir. He used the north light trusses all this. And you find there's no need of light, artificial light there. So therefore, what you need to do is that what kind of opening you do it. What is, depth of the room and width of the room. You make sure that light reaches the last corner and you make optimum use of the north light. And secondly, your living area, they are like you want to do naturally you want to have the best of climate in the area where you live it. So you have put it in the best orientation. Like if you have your bedroom put in the western side, you will be all lost. And I explained to you in the hill areas, if you design your building on the northern slope, you are totally lost. So you have to evaluate. I think you will do what one thing. Please map out north, south, east, west. What are the positivity or north? What is the negativity or north? So all these four directions, if you understand, you will be able to see how you are going to put the building itself, how you are going to place your building. Like north light. North, sun never goes there. So there will be no sun, there will be no heat, but light will be uniform. So where you don't want any heat, you want only light, you don't want any sun, go for north. South, you have one. Like south, in the summer, the sun is vertical. In the winter, sun is horizontal. In winter, you need a sun. In summer, you want to cut off the sun. So what you do in the southern side, whatever you provide, you have a horizontal projection and which will cut off the sun. But you have to design that horizontal projection. On east and west, you will have to have vertical louvers. So they will have to cut, but depending upon what is the slope, how it is coming, they will be in opposite direction. Whatever you do in the east, it will be in the west, and you will have minimum opening on the western side. So even if you have something because you can't avoid western side, then you can have creeper, green wall coming in. Those can be there. You can plant, trees on this. That can all be done. You can have a deciduous trees. The
Um,
deciduous trees one which in summer they will have all the those leaves. They will protect you. In the winter, the leaves will go away and you can have the sun. So there are a number of methods you can do. All cases, well, all building design will challenge a new kind of, and because buildings, I said, are responsive to the site, and the climate. And you will find no two sites are similar. And that's what, you have to, I said, when you study the climate, you will study the regional climate, city climate, and the site climate. And site climate remains very, very important.
Okay, sir. So we have one last question. This is that how can we make our buildings breathe or regenerative along with making it green, and except for using green roofs and green facades? Like what else can we use to make our buildings regenerative?
Look, you want to, in a hot area, when you're doing it, you are cut off function. I said you will have those, cavity walls. Number one thing. I give you, you have minimum area exposed to the western side. Brick, you can have those kind of things. And then, by a minimum opening on the western side. You can make use of south, you can make of southeast, huh? And you can use, like I was saying, on roof, in the roof you want to do it, because roof will go on, roof is one which is exposed to sun. So what you can do is, I said you paint the roof white, or you will have a green roof. You can also do what, you can have, there were people who were doing this. You can have these tiles. You can put on that. They will, white tile will reflect. There are other things. खसखस होती है ना, उस पर भी अगर लगा दें, उस पर पानी छिड़क दें, तो evaporation causes cooling, They are the other method which have been used. So this is what you have to see. Like now, what the people are doing is, like आप फोटोवोल्टिक सेल लगा देते हैं. सो छत पर जब फोटोवोल्टिक सेल है, तो उसमें क्या है, you are getting what, you are getting electricity, but the photovoltaic cell, that panels, they also cast shadow, and they also keep it cool. So therefore it is, it is basically side to side, and this is what you have to do it. You can have, it's not that you do a straight, you can have even a slanting roof itself. You can do a building and which have minimum, opening, and on the site which is very, very hot. So therefore, it's all orientation basically, how the building is oriented, how the site is available to you, which is the good side and which is the bad side. And then you have to plan your buildings accordingly. And then, if there are, like, you are in a hot area, you can reduce distance between the building itself. So buildings are shading, like, you have gone to Jaisalmer, you have found, the buildings are high, and they have inner courtyard. Courtyard, it remains one of the best option, because courtyard is one which absorb a lot of heat itself. And all this coastal area also, they also keep it. And if you have plantation and a water, you need humidity in hot and dry area. In case of hot and humid, you have to take off the humidity itself. You can have dehumidifier, etc. But I'm only saying that green building does not mean you don't need a mechanical system, because nature is not predictable and everything is not basically what you want to be. It can change anytime. So therefore, what is trying to say is make best use of the nature other, and you have to have a sports system, but you can reduce the amount of air conditioning which is, because if you are to do the air conditioning, then what you are going to do, you are going to place your living room, etc. You can divide the two areas, like areas which are for human living and the area which is not for human. For now, there is no human living. That means it is not to be done by those passive active those air conditioning. It can turn on the few area. That is number one. You are reducing. Number two, it is only used as and when it is required. So passive means you are designing with nature, you are designing with orientation, you are designing with climate, you are designing with air, etc. And that should be, that should give you the solution.
Definitely, sir. Sir, there's one question about using terracotta tiles. Like, how do they affect this whole system?
Terracotta, anything earth, earth is earth is the best material you have, It can absorb heat, it doesn't transmit the heat. Terracotta is there. So terracotta, all those in all these coastal areas, people are all having slanting roof and they're using terracotta, So terracotta remains one which doesn't allow the heat to be transferred here. So but that will be used only when there is a lot of rain or there's snow so that water immediately takes off. So the only thing you have to be very clear is water does not get accumulated in the building. So these are sloping roof, all hill areas, they are only having the sloping roof. Unfortunately, in area, people have done away with those the sloping roof. That's the greatest crime we are committing because, you know, this roof shape is, I said, you will see what is the rainfall, what is etc., so that water does not stay and water is drained off. So in all hill areas where there is snowfall, there is a lot of rain, etc., or in the coastal area, you will have to have roof which is slanting. You can't afford to have roof, which are plain roofs. So terracotta is one which have been used, that was locally available, that can be immediately put in this. And if there is some in or you can't have those sloping roof with concrete, etc., that is doing very, because then it will crack. In case of terracotta, if there is some damage done, you can replace that portion also. So they are basically the option which are available to you. But if you study the old buildings, you will immediately come to know why those people used those kind of local material. Then it remains that is the context you have to see. Anything else?
No, sir. Thank you so much, sir, for being here. Rest all, I believe you have already covered building features, green building features, climate responsive
Let me
architecture.
tell you, designing building is something very different and distinct. Let me tell you. If you read a book how to swim, and then you jump into the canal, what will happen? Surely there is no survival. Because if you read the book, that doesn't mean by simply reading a book. Ultimately, you have to design, you have to use your ingenuity, you have to, now there are software even which will tell you what is the energy consumption level of a building. Those, your design can even be basically be evaluated on that terms. So therefore, it is a practice, it is understanding, it is a site. I said they are different, and architecture, has its own role and relevance, and our architects, with your ingenuity, surely you can come out with the building which is more sustainable, because I told you what are the method with you for to reduce your energy consumption and water consumption. In energy, it is only using the natural energy. Sun, you have best is the source is the sun, And in case of water, I said you have to do the recirculation. And ultimately, there are methods which I explained to you how you minimize because the water is being used for this all your taps, etc., WC, etc. That's a different thing. I should have gone into that, but the very detail, how the water, what is the amount of water goes in WC, in the kitchen, in your bathing, etc. So they are the different things. But surely, I given you the principle, like you have, aerator coming in this, then you have recycling. If you have two kind of things, you can collect gray water and the black water separately. Gray water can be used for your gardening. It can go for WC, flushing also. It can use for car parking, this car washing, etc. Whereas only black water requires recirculation and treatment. So once you do kind of
Yes,
things, that can reduce, that can help you in gaining this kind of thing. So
yes,
you
sir.
have, so
Thank
those
you
are
so
the
much,
things,
sir,
right?
for this detailed, insightful session. We are so grateful to have you here, and heartfelt thank you to all the audience for staying with us. So, yeah, with this, I would like to conclude our session. Thank you so much again, Architect Jit Kumar Gupta, for being with us.
Thank you, and I'll share with you the PPT, which you can share with the students, right?
Yes, sir.
So if they
Definitely.
even they have a question, they can. My number is 9. They can talk to me. My mobile number is 90 410 26414. 90. I'm repeating 90 410 26414. So if at all they have any kind of issue about a green building, they are welcome, right? That
Definitely, sir. So,
uh,
any of the doubts remaining, you guys can text sir, or you can also reach out to us. Thank you so much, everyone, once again. Have a good night.
and wish you all the best, do a good job. But only thing you have to understand the context, you have to, apply your mind, and there is no substitute to your hard work. I know once you do, you start enjoying your designing and you will do a great job. Thank you. Thank you very much.
Thank you, sir. The audience can leave the meeting. The session is over. Thank you.